Hi everyone, this is the review for test 1. Here I have several questions from different topics of test 1. So let's start by the first question. The first question states the domain and range for the following relation. Here I have a relation. As you see, there are several pairs here, 0 and 9, 1 and 9, 2 and 9, 3 and 9. 0 is in relation with 9, also 1 it's in relation with 9, 2 and 3. So what is the domain and range for this relation? Domain, it's a set, and this set includes the first component of each pair. So from 0 and 9, 0 belongs to domain. Between 1 and 9, then second pair, 1 belongs to domain, 2 and 3. How about range? Range is the second pair, the second component of each pair. So between 0 and 9, it's 9. Between 1 and 9 is 9. Between 2 and 9, range is 9. And also here is 9. Range also is a set contain all y values in the pair of x and y. 9 is just one constant, and I'm not going to repeat it 4 times. The range is only 9. Now, the question is if this relation is a function or if it's not a function. Pause the video and think about the problem. What do you think? Do you think it is a function or it's not a function? Okay, now, what is your answer? When we have a relation and we want to check if this relation is a function or not, our job is to look at domain 0, 1, 2, and 3. If there is any pair with the same exact domain, for example, if there is here 0 and 1, for example, and you see 0 2 times as domain, 0, 9, 0, 1, then your job is to check if the second components are equals to each other or not. Here I have 0 and 9. If again I have 0 and 1, then I'm going to check if 1 is equals to 9 or not. If they are equals to each other, I mean, if I just repeat 0 and 9, it's okay and still is a function. If not, and I have 0 and 9, 0 and 1, I know that 1 is not equals to 9, then it's not a function. Now, to check a relation is a function or not, your job is to look at the first domain. 0, 1, 2, 3. Is there any domain that is repeated? No. So this is a function. This relation is a function. And if there is a repeated domain, for example, 0 and 1, now your job is to check if 1 and the 9 equals to each other or not. If they're not, then this relation is not a function. But in this case, yes, this is a function. Second question. Here we have y equals positive square root of 9 minus x squared, y equals negative square root of 9 minus x squared. And the question asks you whether the equation defines y is a function or it's not a function of x. In the previous example, I mentioned that you check x and y value, this pair, to see if a relation is a function or not. If you can find two pairs, x and y, 1, also x and y, 2, x equals to x. But if you checked and y1 it's not equals to y2, then the relation is not a function. If y1 it's not equals to y2, then the relation is not a function. It means that if we have the same input for a relation, but the same input gives us different output, then that relation is not a function. Now let's back here and check if this relation or this equation is a function of x or not. Here you see that we have y equals positive and negative, and then some statement like square root of 9 minus x squared. It means that if we have x equals something, like for example 1, then what is y value? We get y equals positive and negative square root of 9 minus square of 1. So it's positive and negative square root of 8. You see that when input is 1, output 1 time, we can see it as positive square root of 8. And at the same time, the answer can be negative square root of 8. We have the same exact input, but the outputs are different. When we have x and y1, x and y2, x is equals to x, but y1 is not equals to y2. This relation is not a function. The same for the equation. If you have the same input for the function and you get different outputs, then this equation cannot represent a function. So this is not a function.